name is Jackie Sherry, and I'm with the Athens-Clarke County Public Utilities Department, specifically with the Water Conservation Office. Today, I want to talk to you about my favorite molecule, the water molecule. Water is truly magical. It can even defy gravity by traveling from this beaker here to this cup on this piece of yarn. Today, we're going to learn just how water can move along this yarn from the beaker to the cup. But first, we're going to learn some fun facts about water. Water is colorless, odorless, and tasteless as a liquid. And did you know that water is the only compound that can exist not only as a liquid, but also as a solid and gas under natural conditions? Here's another fun fact. Water is a chemical compound. Each water molecule, or H2O, consists of 2 hydrogen atoms bonded with 1 oxygen atom. The nature of water molecules causes it to be attracted to other water molecules as well as molecules of other substances. For example, have you ever noticed how water drops form on top of a car after it rains? The water almost beads up on the car. It does that because of the various water properties known as cohesion, adhesion, and surface tension. Cohesion is the attraction of water molecules to each other. Water molecules are attracted or stick to each other, like the raindrops beating up on the surface of the car. Adhesion is the attraction of water molecules to other materials, like water attaching to the car or water absorbing into soil. Surface tension is the attraction of water molecules at the surface of liquid. This causes the water surface to behave as though there is a thinly stretched membrane across it. Think of surface tension like an invisible layer of skin over the water. Now let's put these properties to the test with some activities. For our first activity, you're going to need a cup of water, a pipette or eyedropper, and a penny. And we're going to see how many drops of water we can get to stick to the surface of the penny. First, we're going to fill the eyedropper with water. Then, slowly add drops of water to the surface of the penny. As you can see, the water molecules are sticking together and forming a bubble on top of the penny. This is showing cohesion because the water molecules are attracted to each other. It is also showing adhesion because the water molecules are sticking to the penny's surface. Looking at the bubble, there is a film or membrane over the bubble, and this is what is known as surface tension. When the surface tension is broken, like this, the water will spill over the penny. You can try this at home and see how many drops of water you can get to stick on the surface of your penny before it spills over. I bet it's more than you think. And helpful hint, make sure your penny is dry. For our second activity, we need a cup of water filled to the very top and about 50 pennies. And I'm going to slowly add the pennies into the cup of water and observe how that changes the surface of the water. I'm going to start by slowly adding pennies into the cup. You can see cohesion in play by simply looking at its surface. This glass of water is filled to the brim, and as you slowly add more pennies, the water level will rise, exceeding the top of the glass. Eventually, as you continue to add more pennies, the surface tension will break and the water will spill over the edge. You can try this at home and see how many pennies it takes before the water spills over. You can also challenge a sibling or even your parent to see who can get the most pennies in the cup. For our third activity, we need an eyedropper, a cup of water, and a maze covered in wax paper. I'm going to start with a drop of water. A small drop of water works best, and then you can either use a pipette or your finger to move the water drop along in the maze and make it throughout the entire maze. And you'll notice the water molecule is not only sticking to my finger, but also sticking together, demonstrating cohesion. You can try this at home to see if you can get your water drop to make it throughout the maze. Again, you could use a pipette, your finger, or even a straw to move your water drop. Again, you could challenge a sibling or a parent to see who can make it through the maze first. For our last activity, we need a cup of water, some paper clips, and a fork. And we're going to see how many paper clips we can get to float on the surface of the water. Place the paper clip on top of the fork and then slowly try to get it to float on the top of the water. The high surface tension means that the paper clip can float on the water. But as soon as the surface tension is broken, all of these paper clips would sink to the bottom of the cup. You can try this at home and see how many paper clips you can get to float on the surface of the water. Again, you can challenge a sibling, a friend, or your parent to see who can get the most paper clips on top of the water. These are some of the activities you can do at home that demonstrate cohesion, adhesion, and surface tension. You can visit thinkatthesink.com under our virtual education section to find a worksheet that will help you follow along with these activities and track your numbers. I hope you all agree that water is truly magical. It's a precious resource that we need to conserve. Now is the time to start thinking about your water use and use water wisely, because if you don't, it could be gone. Thank you so much for watching, and please visit thinkatthesink.com for more water conservation tips, videos, and interactive activities.